When AI systems fail, the response has to be fast, controlled, and auditable. In this lesson, we'll connect NIST CSF respond and recover to real AI incidents, including prompt abuse, harmful outputs, breach handling, disaster recovery, and model rollback. So far, we've built the groundwork: inventories, data flows, regulatory duties, safeguards, and detection controls. Now we move into operations: how teams respond when AI systems fail, are abused, expose data, or need recovery. Respond and recover are where cyber resilience becomes operational. For AI, response goes beyond servers and accounts. Teams may need to analyze model behavior, prompts, embeddings, training data, inference APIs, logs, integrations, and downstream decisions. Containment might mean disabling a model, rotating data access, or pausing an automated workflow. Recovery then restores service, validates integrity, communicates status, and confirms the AI is safe and trustworthy again. Consistent classification turns a chaotic AI event into a managed response. Start by naming the incident type: security, privacy, model failure, abuse, or availability. Then rate severity based on real-world impact, including possible harm, PHI or PII exposure, regulatory consequences, users affected, business disruption, and whether the issue can repeat. That rating should route the case to the right owners, from security and privacy to legal engineering, clinical leadership, compliance, and executives. AI abuse needs dedicated incident playbooks because the signal may come from a prompt, an output, or a pattern of user behavior. Define intake from reports, alerts, monitoring, SIEM, and support. Then triage the key questions: what was asked, what was generated, did sensitive data appear, and could harm occur? Containment should be explicit: block prompts, suppress outputs, rate limit, suspend accounts, and trigger model behavior review, so each case improves the next response. When a harmful response appears, don't start by tweaking the model blindly. Preserve the full exchange first: user prompt, answer, logs, retrieval sources, model version, user, and time. Then assess the harm, such as a policy violation, sensitive disclosure, unsafe advice, or prohibited enablement. Containment should be targeted: block a pattern, disable a feature, remove bad source content, or tighten guardrails. Finally, feed the lesson back into detection, red team tests, and safety evaluations. These events should be handled like cyber incidents, but with an AI-specific blast radius. A stolen token may expose prompt logs, embeddings, vector stores, fine-tuning data, or model artifacts. Misused access can trigger unsafe automation or compromise connected systems. Response starts by identifying every affected asset, then containing quickly. Rotate keys, isolate endpoints, revoke privileges, shut down risky integrations, and segment networks if needed. Before restoration, confirm whether PHI, PII model weights, or business logic left the environment. An AI breach is both a technical event and a governance process. First, classify the intake: security incident, privacy issue, AI abuse, or breach candidate. Then investigate where sensitive data appeared, including prompts, logs, outputs, embeddings, or decision records. Contain exposure quickly while legal teams assess HIPAA, GDPR, and notification duties. Communications should be coordinated, not improvised. Throughout the process, preserve evidence so the organization can support audits, explain decisions, and improve controls. During an AI incident, evidence can disappear quickly. Logs rotate, prompts change, retrieval indexes update, and model versions may be replaced. Preserve the full trail early: gateway and application logs, IAM and cloud records, SIEM events, data store activity, prompt response pairs, system prompts, retrieval context, guardrail results, and inference metadata. Then protect integrity. Document who handled each artifact, why it was collected, and avoid undocumented configuration changes that could contaminate the investigation. Once an incident is confirmed, the response moves in parallel, not in a straight line. Technical teams contain the issue by disabling endpoints, revoking credentials, blocking prompts, removing unsafe data, or switching to fallback workflows. At the same time, privacy, legal, compliance, product, and security assess who was affected, what data was exposed, how long it lasted, and the likely harm. Those facts drive notification duties under HIPAA, GDPR, contracts, and internal thresholds, followed by coordinated communications. Disaster recovery for AI is not just about bringing servers back online. It starts with knowing which services, data stores, models, APIs, identity systems, monitoring tools, and vendors the business depends on. When something fails, the plan should define safe alternatives: degraded mode, manual review, rules-based fallback, an alternate model, or temporary suspension. Restore first where downtime creates the greatest safety: customer, regulatory, or operational risk. iRecovery planning has to cover the full system, not just the database. That includes model versions, prompts, policies, feature stores, containers, training snapshots, evaluation results, and audit logs. RTO defines how quickly the service must come back. RPO defines how much recent state the organization can afford to lose. The practical control is regular, owned backups, followed by restore tests that prove the backups are complete, secure, and usable under real recovery conditions. When an AI service is disrupted, failover is more than moving traffic. The runbook should declare the event, activate the approved fallback, and confirm users are protected. That fallback might be another region, a backup model, an alternate provider, cached responses, or a manual review process. Before normal service resumes, validate identity controls, data integrity, model version, guardrails, logging, and integrations. Then monitor closely with clear rollback conditions if behavior degrades. Rollback is the safety net for model operations. When monitoring detects harm, drift, latency failures, bias, or compliance issues, the team should not improvise. It should restore a previously approved model, prompt, guardrail, or configuration from versioned records. But rollback still needs control, approval, regression testing, security and privacy checks, bias evaluation, and monitoring confirmation. Afterward, document the root cause, impact, approvals, and corrective actions so the same failure is not repeated. Respond and recover is where AI governance becomes operational resilience. You should now be able to recognize AI-specific incidents, support coordinated breach workflows, protect recoverable AI assets, and roll back unsafe deployments. Next, we'll connect these practices to compliance control mapping and audit-ready evidence.